Hello guys, and welcome in this new recording. We continue today on this damaged helmet display. So if you remember in the previous video, we were trying to display this model already, but we actually just failed because there were a lot of issues that had to be sorted before we could get to this result. Yet, I've been working on that. Not that much, actually, it didn't take that long. And as you can see here, we have now a proper rendering for this model. So that is very cool from my perspective. Yes, we have all the PBR elements. So we have the roughness, metallic aspect of the material, and we also have the normal normal mapping in place. And additionally, we have the emission texture, which is now supported. This is not really part of the PBR rendering itself, but you can easily add that as part of the shader at the end of it. At least that's what I did, and it's working properly, I think. So what we're going to do in this video now is try to give you an overview of what were the issues and how we have been resolving them progressively. But maybe just before that, just to demonstrate that the PBR effect is working fine. If you change the environment mapping like that, you get a different luminosity and different reflection for your model. So everything is really working fine. Okay, so let's get started. What should be the first point to mention on this one? First thing is probably, yes, the introduction of the support for definitions in the shaders. What I mean by definition is, well, it's going to be tricky to show you that because I think in the end I don't need any kind of definition, direct definition in the shader, but still, here's the actual WGSL program shader file, and we already add support for those entries, those kind of entries. If define a given value, then we are going to keep this section, and otherwise we're going to keep this one. So this is not new, and now I'm starting to kind of accumulate a few of those. So I think it's pretty handy if you want to build a shader in a flexible way, I would say. So you have one here already. But what I had in mind at some point was to try to define entries directly in the shader. So you could do, for instance, define in the option 1, and you could set this value to 42. Okay, something like that. And so this was not supported up to this point. And now we have added support for that. And in fact, I think I have a unit test where you can see how this is going to work. So here it is, for instance, because initially this is what I wanted to do. I wanted to provide the channel index as a defined value like this one, and if it was not defined initially, you could provide a default value directly into the shader like that. So yeah, testing this, you are providing this as a source, and then you're going to reprocess this source, and your expected result would be something like that, because you're just replacing your definition value by the actual value, and all of those lines basically should disappear. So this was the expected output. Yeah, you're also going to try here to provide an overriding value outside of the shader. So this is what I do here, for instance, for the metallic channel. you see that the expected value here would be 3 instead of 1, but you're going to process the same source, but this time you're going also to provide those additional definition, and in those definition I'm specifying that I want to see this metallic channel to have a value 3. And yeah, this unit test is working just fine. So yeah, this is now available in the shaders, but not using in this one, because in the end what I'm using is simply this one. If it's not defined, then you are going to provide your texture, and if it is defined, let me see, yeah, in the actual computation part you get a different behavior, and you're not really relying on the channel number anymore. You're just assuming that the channels are distributed like that. Okay, so this is it for the definition part, but was not really a big issue in the end. Another thing I was mentioning in the first recording was an issue with the simpler definition in the GLTF library. When you're trying to load the GLTF model, I was actually getting an error. Probably for this one I should show you what was the actual error. So yeah, we were receiving something like that, unsupported filter type, and at first I was thinking, okay, maybe there's something wrong in the GLTF library, and you need to provide some default values. But yeah, like most of the time when you actually suspect that there's something wrong with the libraries that you're using as a dependency, it's rather in your own code that you have an issue. So in my case, it was because of the function that I'm using to report an error message. This function was actually displaying characters after the last one because we were not really providing the correct size for the character string. So no really need to go into those kind of details. And also the fact that in my function, the one I used to get the filter, let me try to find that. In this one, I was not really defining the case where you get a 0 value, because in fact, that's really the default value you get from the simpler structure in the GLTF library. So yeah, in the end, when you see 0, you're going to just use linear, and this is fixing the issue. What else? I had another problem then, because basically in my processing here, I built some of this processing reworking on what was available from the Web GPU native samples repository. So I made some modification already, and for instance here I was expecting that the image would always have a name, which is not true. Names are not mandatory. And by the way, concerning this, if you need details concerning the GLTF specification, you really want to have a look at this page, so the specification page. And for instance, the part which is very interesting is properties references. And for instance, if you go into simpler here, you would get this description, and you clearly see here that none of those elements are actually required. So you could just have those not specified at all, and you get a default shade, simpler. So same thing for the image. If you go on the image, you will see that the name is not mandatory. So you could really have an image without a name. Again, nothing is mandatory here. But you have some condition then to take into consideration. For instance, you have the buffer view here, which must not be defined if you have a URI, and the opposite, maybe not the opposite. Well, never mind. So I had to fix some of those additional minor problems. And after that, this actually led me to another consideration, which was kind of a big part, if you want, because in the initial version, basically, what I was trying to do, let me get back to the, well, very initial version, I was trying to do something like that. So I was providing the model file and then trying to load the images separately. But then I started to think about that and came to because I had some issue also when trying to load the GLTF model, because by default it would also try to load the images that are defined in the file, and those images were not found because I was storing them in a different folder, in my texture folder. So this was going to be some kind of conflict actually, and thinking about that, I decided, okay, probably the most appropriate way to handle this now is to go fully forward in the GLTF model and try to add support for the materials in this object loading process. So this is what I did, and now we also have this part where you're going to do the loading of the materials, and you will in fact create new material object and assign all the images and texture that you are created directly from the GLTF model into this material object. The object the class definition, I mean, is pretty simple. Currently, it's just storage for a few textures and the immersive factor, which I'm not even using. But anyway, we can consider extending this further then when I get more complex materials, I guess. So when using that, I also had to update the, this draw PBR method from the scene. So in my scene now, when it comes to draw this PBR, what I'm going to do is try to load the model directly and try to get the first material that I have in the list. Currently, this is still a bit, well, simplified implementation. I'm really assuming that I will get at most one material defined. Definitely not something generic, but it's a start. And so if you have such a material, then you're going to access that, and you may actually use that to provide some default texture if you're not overriding them from the construction information structure here. And this makes me think that, yes, here I was trying lately to add support for immersive, the immersive mat, but I need, all of them. This is not quite correct because you could still have no material here, so I need to fix that. Well, I get back to this offline. And okay, so this is it for the material introduction. Then another big part that had to be fixed was that in the GLTF model for the damaged helmet, we didn't have any tangent attribute. Let me just get back to the model file. And if you search for the primitive, here you see that we have the normal position, texture coordinates, but we don't have the tangent. And we need the tangent to be able to apply the normal bump mapping correctly. So I also implemented a mechanism to actually generate those tangent on the fly when you're building the model itself. Where will this be defined? Students is loader, right? Let me check. Generate. Yes, that's it. Generate tangents. This is the main function that we're going to use to do the generation of the tangent. It's well, non-completely trivial process if you want, because to generate those tangent, I have a mechanism here where I'm going already to collect all the attributes for a given primitive, and I'm going to place all those attributes into a buffer containing all the vertices. But then for each vertex, you would have one of those attributes. So basically, you could start from separated buffers, first buffer for the position, another one for the normals, and another one for the texture coordinates. But in the end, what we're going to do here is to create a big buffer where for each vertex, you take the first position, the first normal, the first texture coordinates, and then you move to the next vertex. You take the second one, second position, second normal, second texture coordinates, and so on. So you're interleaving your buffers this way to prepare your final vertex buffer. So in case you don't have the tangent attribute available, what I'm doing is I'm still preparing some space in this big buffer to store the tangent per vertex, but initially this will be set to 0. And then when I'm done collecting all those input attributes, this is the time where I will finally try to generate those tangents. So I'm not accessing those attributes anymore. I'm just relying on the existing vertex buffer where you have those interleaved attributes. And so you start with this vertex buffer where you have 0 value for the tangent, but next to that you could have the position value, and next to it you could add the texture coordinate. So you're going to use some of those elements of this buffer to fill the other elements. So not absolutely trivial, as I said, but it seems to be working, so I'm pretty happy with that. I should probably give it a try one day and try to build some kind of unit test for this. But for now, let's say I don't really have the time for that. So yeah, when you get to generate the tangent, you use your vertex array, you get different offsets depending on what you're going to consider, and you're going to do some kind of processing to basically compute the tangent per triangle, and then you're going to accumulate that and renormalize the tangent. Okay, what was the next thing? Okay, it's time maybe to show you what was the result at this point, if you can call that a result. So was fixing the transient materials, fixing the tangent, and ta-da! Here is what I got. Not so good. Okay, I admit. But it was a first starting point, at least. From that point, then I had to first flip the model vertically. So this is what I did, and also at the same time, what did I do here? Probably this was when I was trying to flip the V coordinate of the texture, because I thought it felt like maybe this was part of the back side of the helmet. So maybe it's just a flipping of the texture, because sometimes this may be necessary, but yeah, not quite. I mean, it's strange because this doesn't really look like this one. What else did I change? Because the flipping of the V coordinate is a change between here and here. Never mind, it was not very good anyway. But still, at that point then, I was trying to investigate what were the value for the UV coordinates in the GLTF file. And the good thing is you actually get the min and max value reported. I don't think this is mandatory either, but in this case, they were provided, and that was exactly the hint I needed to figure out what was happening. Because if you look at this part, for instance, you see that the coordinates are actually between 1 and 2, basically. So you are outside of your 0, 1 standard square area. And I remembered at that point that I was using a default simpler in my processing, and the simpler was using clamp to h, the wrapping value clamp to h. So it was definitely not going to display anything for values that are outside of 0, 1. And so I have changed that, and if you just change that to repeat, you instantly get something much more appropriate, even if it's still completely wrong. At least now you see that the coordinates are working. And after that, then I had actually to revert the flipping I did on the v coordinate, and you got that result just after. Here I was actually disabling a few of the PBR effects. You will see, for instance, that there is no normal mapping, because yeah, I didn't want to try to fix everything at the same time. So this was coming next. So yes, I have then added the normal mapping, I guess, and I had to handle another small issue. This one is not really related to this helmet, I guess, in itself. It was more on the PBR rendering process itself on this line. I actually noticed that if I was using a simpler, which were configured with repeat for the wrapping, this was going wrong, because the roughness value here could go to 0, and if it goes to 0, you get this strange gray artifacts. And I spent some time actually trying to investigate this one, and the best option that I found at the end is this small clamping that I'm doing here. If you clamp that to a value slightly above 0, then the effect is gone. Okay. Next, I have added support for those empty location in a bind group, because when I was playing with this shader, you will notice here at the top that you're starting to get a lot of bindings. And if you, for instance, decide that you don't want to, this is what happened with the metallic texture before I moved that to the end. The metallic texture was defined somewhere in the middle here. So if you decide that you don't want this entry anymore, say you would like to remove this one, for instance, then in my system the problem was, okay, you have the binding at location 7, then the next one should be location 8. So you would need to again update all those entries to take this change into account. And then if you think about it, sometimes you may have situation where, for instance, you have an emissive textures, and other times you don't have this emissive textures. So you may end up in a situation where you have to accumulate some of those binding entries, but some of them might not be available at some point, which could prove very hard to write in a static way if you are always incrementing the location with your existing bindings. So the proper way to fix that, I believe, is to introduce a support for an empty binding location. So for instance, currently this one is empty. It's the location number 4 here is not specified. We're moving directly from 3 to 5. And so this is what I'm using now. when I'm building the scene, when I'm building the PBR in the scene. So let's get back to the scene here. At the end, you will see that you have a few conditions that may change the binding that you will provide. For instance, this one, which is going to check if you have the same texture for the metallic and the roughness components. And if it's the case, it means you actually don't need to provide the texture twice. So in this case, what I'm going to do is to not provide the metallic texture. And so you have here the definition of all the bindings, and you see that I have the first one here, second one, third one, fourth, and then this one, bind node none, means I'm not going to put anything in there. So I'm going to jump to the following location in the bind group. And then you can have some condition like this one, for instance, depending on if a condition is true or not, you're going to put something in a given bind location or not. And now I'm using this also for the immersive part, which we'll see very shortly. Okay, so this was it. And then another side effect I noticed. Initially, I had a problem also on this model because the UVs were again outside of the square 0, 1. And now that I have replaced the default simpler with this linear and repeat simpler, you don't have this effect anymore, and this tube here is going to be rendered properly in this model. And finally, as I said, I also introduced support for the emissive texture. This one was pretty... well, I made it pretty easy. I'm not absolutely sure it's the best way, it's how people are doing it normally, but what I'm just doing here is I'm checking if I have the emissive texture, and if it's the case, I'm providing that as part of the bindings, and also specifying this entry. And as you've seen already in the shader, if this is specified, you have this declaration, and then you have just an additional line here to add the emissive contribution to the final color. I should probably take the emissive factor into account also here, and actually to also let you know about that, initially I was doing this before the tone mapping and gamma correction, except that if you do that, the emissive color gets amplified significantly, and you actually, since it's a JPEG texture, you have some artifacts here. You can see maybe those slightly red and green pixels all around. They are coming from the emissive texture, and if you bump those colors up, you start clearly seeing those small squares, actually, because these are really squares around the actual content. So to me it seems better, for the moment at least, to just add the emissive color after the color mapping and all. But we'll see. Maybe this is something I'm going to change eventually if I get more knowledge about it and I understand that how you should do it more properly, I guess. And I think now this is it. We have covered everything concerning the updates that were required to be able to render this object. And again, as you can see, our results are fully satisfying. I have in fact been using another element as a reference, because if you go, I think you have a link for that. Yes, this link here. If you follow this link, you will get to the, I guess, original source provider for this model. And you can have this 3D display, and you see how the model should look like. So to me, yeah, it seems to be pretty similar to what I can achieve here. And yep, this is it from my perspective. I hope you learned a few things here, and thanks for watching in all cases, and see you another time. Bye bye.